we're going to pull back the curtain on something you use every single day. I'm talking about your computer, your phone, and we're going to reveal its secret origin story. And here's the twist. It's a story that doesn't start in some sterile lab. Nope, it starts in the glowing, noisy, chaotic world of video games. All right, let's just dive right in. Okay, just for a second, I want you to picture this. Imagine a world where that super fast, visually stunning digital life we all just take for granted, well, it just doesn't exist. Every tap on your phone is a laggy mess. Every image is just a bunch of pixelated blocks. Sounds like a total nightmare, right? Well, believe it or not, that alternate reality, it was a very, very real possibility. So what saved us? What pulled us back from the brink of that technological dark age?
You might be surprised by the answer. It's video games. Yeah, that's right. It was the relentless, absolutely insatiable demand from gamers. People wanting better, faster, more immersive experiences. That was the hidden engine, the secret force that literally propelled us into the modern digital age we know today.
So to really get how this all happened, we've got to go way back. Back to the very beginning. We're talking about the arcades, where the first digital battles were being fought. And these weren't just battles on the screen. They were happening deep inside the machines themselves.
Just think about it for a second. Back in those early days, just getting a single character, what they called a sprite, to move smoothly across a screen, that was a massive engineering headache. But here's the thing. Gamers didn't care about technical limits, right? They just wanted smoother animations, more detailed characters, a better experience. And it was this constant demand, this constant pushing, that forced engineers to innovate. They had to push those early processors to their absolute breaking point, and in doing so, they laid the essential groundwork for pretty much everything that came after.
But, that early push? That was really just the beginning. The real turning point, the invention that literally changed the game, was born from a much bigger need. We're not talking about just one little sprite anymore. We're talking about rendering entire 3D worlds.
And the key to this whole revolution, it's a concept called parallel processing. Now, what's that? Well, instead of doing one really complex thing after another, it's all about doing thousands or even millions of simple little tasks all at the exact same time.
Okay, let me put it this way. Think of your computer's main brain, the CPU, like a master chef. He's a genius, right? He can handle any complex step in a recipe, but he does them one at a time. Now, a graphics processing unit, a GPU, that's totally different. A GPU is like an entire kitchen packed with line cooks. Each cook is only doing one simple thing, like chopping a single carrot, but they're all chopping at the same time. The result? A massive amount of work gets done almost instantly. And this is perfect for graphics, where you have to figure out the color of millions of pixels all at once.
So this incredible need for parallel processing, it kicked off a full-blown technological arms race. Gamers wanted more and more realistic worlds, and you had these companies like NVIDIA and AMD competing like crazy to deliver the most powerful GPUs to make it happen. And this competition, which was fueled almost entirely by the gaming market, just accelerated GPU development at a pace that was, well, it was absolutely breathtaking.
And it wasn't just about graphics either. See, the demand for bigger, more complex games, it started this massive chain reaction that ended up upgrading the entire computer, from top to bottom.
So here's how that ripple effect actually worked. You had gamers demanding these huge, seamless, open worlds with zero loading screens. The problem was, the hardware back then just couldn't keep up. It created this massive bottleneck. So, what was the solution? Well, the industry was basically forced to develop much, much faster memory, that's RAM, and a totally new kind of storage, the solid-state drive, the SSD. And the crazy part? The reason your computer boots up in a few seconds today is all thanks to gamers who just got sick of waiting for the next level to load. Wild, right?
And that ripple effect just kept on going. All those complex in-game physics, they required more powerful CPUs with more cores. And what about online multiplayer? The rise of online gaming demanded faster, more stable internet, which directly helped push the development of the broadband we all rely on today. It's all connected.
Okay, so up to this point, we've seen how gaming literally built a better computer. But this is where the story takes a really unexpected and honestly an incredible twist. All this technology that was perfected just for fun, just for play, it started solving some of the world's most serious and complex problems.
Okay, first, think about the AI that goes into a video game. The stuff that makes all those non-player characters act realistically, helps them navigate the world, react to you, and just seem alive.
Well, that exact same AI technology is now being used to train self-driving cars. It's helping them navigate the complete chaos of a real city street. It sounds crazy, but the logic an elf uses to avoid a dragon isn't all that different from the logic a car needs to avoid a pedestrian.
Or how about this one? Virtual reality. VR headsets, they were developed and, maybe more importantly, made affordable for pretty much one reason: to create super immersive gaming experiences.
But today, that same exact tech is being used by surgeons to practice incredibly complex operations. It's used by pilots to train for life or death emergency situations, all inside a totally risk-free virtual world.
And let's circle back to the hero of our story, the GPU. Remember that incredible parallel processing power? It was perfected for basically one purpose: to render beautiful, complex, imaginary worlds. Well, now, that same power is the absolute backbone of modern scientific research. We're talking about everything from simulating how proteins fold to discover new medicines, all the way to training the massive AI and machine learning models that are fundamentally changing our world as we speak.
Which brings us right up to today. Because this relationship between gaming and technology, it's not some story from the past. No way. It is happening right now, and it's actively shaping the computers of tomorrow.
You see, gaming is still the single most demanding thing that an average person can throw at their computer. And because of that, it's the ultimate stress test. It's the ultimate proving ground for every single new piece of hardware that hits the market.
And we can already see the next frontiers on the horizon. Things like cloud gaming, they're pushing our internet infrastructure to its absolute breaking point, demanding near zero lag. And then you've got real-time ray tracing, which is basically simulating the actual physics of light for graphics so realistic they blur the line with reality. That stuff requires a level of raw power that was pure science fiction just a few years ago.
So really, the next time you fire up a game, just remember, you're not just playing. You're actually looking at a blueprint for the future. And that leaves us with one really fascinating question to think about. What future-shaping, world-changing technology is hiding in plain sight right now? Maybe disguised as a power-up or a final boss in the games that we're all playing today.